Hi, my name is Joseph Walsh, and this is my video to continuous systems on the system of a chandelier. Before I get into talking about the assumptions behind the system of motion, I am first going to describe how my free body diagram was drawn. In the picture on the last slide, there were 28 chain links in the entire chain, and as you can see on my free body diagram on the left, I drew 7 links per KE, KE1, KE2, KE3, KE4. That was just to sort of simplify it for myself, but you can simplify it even further and make it into a 1D freedom system where there's only one spring constant among the solid body. Now on to my assumptions. The 4 assumptions I am using are that it is a rigid body system, there is small motion within the system, there is uniform density amongst the body, and that gravity does not act on the system since the spring, the rigid body that we're using for a spring, which is the chain links, is in parallel with gravity. So the forces of gravity and the resistive forces in the springs will cancel out. And then below I defined the chain itself and the light fixture. The stainless steel chain has a density of 0.21186,343 pounds per inch cubed, and the Young's modulus of the chain link is 29.4426 times 10 to the 6 psi. There's 48 inches in the chain, and there's approximately 1 square inch area of the chain links. The light fixture weighs approximately 10 pounds. Finally, we have solved for our equation of motion. I brought the variables over from the last slide, and on the bottom left I have the formulas that we'll be using, which are the formulas for the elastic mass of the system and the elastic spring constant of the system. On the right I solved them on my whiteboard, and on the bottom the equation of motion comes out to be 13.392 x double dot plus 600,000 or 613,387.5 x equals 0.